Okay, let's try number 9. So number 9, our given differential equation is dy dx is equal to 1 over the square root of 1 minus x squared, a very interesting rational function. And our initial condition is y of 0 equals 0. So again, we want to find a function, f of x, that satisfies this given differential equation, and of course the prescribed initial condition. Okay, so let's go ahead and start integrating. So this is going to be, the integral of dy dx, and again we're integrating 1 over 1 minus x squared, and again it's with respect to dx. So remember, we have integration and differentiation, right? This is really d dx of y, and y is our function that we're looking for. So this is just y of x. And well, let's see, just to emphasize, this is very good for you to know. So remember, dy dx is d dx, right, of y, right, or d dx of some f of x, right? And this guy, this is your solution that you are trying to find. Okay, so the integral of 1 over the square root of 1 minus x squared dx is a very familiar integral. If you look at your at the inside cover of your book, and you look at number 16 under elementary forms, you have the integral of, well, let me just write it down. So number 16 in the inside cover of your book is the integral of du over the square root of a squared minus u squared, and that integral is sine inverse of u over a plus, of course, our constant of integration. So let's see, maybe just highlight this, or this is what I'm going to use because, right, I have it right here. So what is our integral? So I'll just continue from here. So y of x is equal to sine inverse of u over a. Well, what's our u and what's our a? So in this case, so here a is 1 and u is x, right? Because this is our a squared. If you want to write 1 squared, that's fine. It's still 1. And then that's our u. So we have u over a, so that's x over 1, which is just x, plus our constant of integration. And so our solution to this differential equation, our general, is sine inverse of x plus c. So again, this is a general solution. So now let's find a particular solution, because we're given a initial condition, right, of y of 0 is equal to 0. So let's use that initial condition. So y of 0 equals 0, right? So that obviously means x is 0 and y is 0. So using our y of x, so we have y of 0 equals sine inverse of 0 plus c. Y of 0 is 0, sine inverse of 0 plus c. And so what is the sine inverse of 0? So that's just 0, right? Because this is asking for what angle gives, what angle is the sine 0. And so we have, if we look at the unit circle, right, there's your angle 0, and that's 1 comma 0, negative 1 comma 0, and the sine is 0, right? The sine is a y coordinate at I guess you could say 0 degrees or pi degrees. But remember, when we work with an inverse function, the cosine, their restrictions are from 0 all the way to pi, all the way to 180 degrees, but not including the 180. So this is just the sine inverse of 0 is 0. So that gives us c is 0. So if we add 0, we're not really adding anything. So, you know, we plug that guy, whoops, not there actually, erase that. We are substituting it into, right, there's our c. So our particular solution is y of x equals sine inverse of x plus 0, which we don't have to write. So there's a particular solution to the differential equation.